Physics 1 Lab 4 Oscillations. We began with a video of a mass oscillating on a spring, and we were told to predict the motion in the x and y direction. We observed the different energy changes between delta K, delta UG, delta US, and delta E, and then we compared these different energy changes with how they were supposed to be with our results. We applied some physics principles here using the fundamental principle of Newton's second law. We were given our mass, which we used to calculate our weight force, and our spring force was needed to be calculated from our K, and we also needed LO for S, which I ended up calculating based off my tracker data. I used the period equation of T equals 2 pi times the square root of m over K to calculate out a K of 6.83 newtons, and then L0 I calculated from my video data, and it resulted in a 0.123 L0. I then used the energy principle to apply the initial energies outside of my while loop for K, potential gravitational, potential spring, and our overall energy here. I applied the four different equations that we know into my code, as you can see from right to the left. I then used both principles of the Newton's second law and mainly the energy principle here to calculate out my gravitational force, my spring force, and then my total force, which was the sum of the two forces previously stated. The K, U, G, U, S, and E are all the same calculations stated from the previous slide. And then the KI, UGI, USI are all the K, UG, and US from the previous slide because we are now having to initialize them while they run in our while loop to calculate out the different delta Ks, delta UGs, delta US, and overall delta Es that we are getting from our data. To calculate out my different changes in energies, I'm using for example, K minus Ki, UG minus UGI, US minus USI, and then to calculate out my total change in energy, I'm summing up these three changes in energy, as you can see going from right to left again, left showing where I am applying this data to my code, right showing the formulas that I'm using and the reasoning behind why I'm using them. To compare my position data, I have my position in the y direction on the left, x direction on the right, and the blue was slightly different than the red, in which it should be because we are not taking into account the fact that there is human hair, drag, and other miscellaneous losses in energy from our prediction model. So while ideally we would want to have these the same, they are not in my case due to the fact that they are not being taken into account, these errors. In order to decrease the differences that are there, we could take into account drag in our code data, and we could also try and eliminate some of the human error by being more accurate while plotting points in in Tracker. Overall, now it's time to compare the energy graphs that we have been given by our GlowScript code. The red line is my change in potential gravitational energy, while green is the change in potential spring energy. And so these are supposed to be how they are seen because they oscillate with the same period, but they are in opposite phases because as delta G UG increases, delta US should decrease and vice versa, which is happening on my graph. The blue line is our delta K, and as the mass gains and loses energy, but this is happening twice as fast as the UG and US, it is beginning in sync with the peaks and the points when UG and US are at 0. However, it is slowly decreasing and going out of phase with the other two. This is due to the fact that there is the human error and the error we did not account for. And my orange line is my delta E, which is a constant straight line at 0, which it should be because our entire system of the spring, the mass, and the earth is not changing energy with its surroundings, so therefore the change in total energy is 0. For the final discussion, what does it mean? The energy principle is satisfied because, as I was discussing on the previous slide, the UG, US, and K are all being shown as they should be in line with the fact that the system is just the Earth, the spring, and the mass itself. And now to compare the position of or periods of oscillation for the X and Y position data, you can see the two numbers that I calculated out using my tracker data here. And the periods are obviously not the same, but very close. It is most likely due to the fact that the period in the Y direction is represented by vertical motion like a spring, while X is represented by motion like a pendulum, and therefore slightly different. And that concludes this lab. Thank you.